So in this lesson, we're going to learn about what I call HL90, which is a special congruence condition that only works for right triangles. It's typically called HL in other textbooks without the 90, but I like my congruent statements to always have three parts. Plus, if you're going to use the word hypotenuse, then you need to have a right triangle anyway, so I've expanded it to call it HL90. I'll show you what I mean by this. Let's review some terminology. You may have heard, I suspect you have, that if you have a right triangle, this side across from the right angle, which is always the longest side, is called the hypotenuse. What is not as well known is that these other sides are called legs. So a right triangle has two legs and a hypotenuse. The hypotenuse is the longest one that's across from the right angle. So if we're working with right triangles, we might end up with tick marks in a pattern that looks like this. Here's my right angle, and I have the right angle, and then I have a leg tick marked, and then I have the hypotenuse tick marked. So this is hypotenuse, leg, 90-degree angle. Now, this tick mark pattern is not typically a congruence condition. And this is the SSA pattern, and we've discussed the subtle reasons why SSA doesn't qualify as a congruence condition, because there could be two triangles in an ordinary circumstance if there's an SSA with the given SSA information. However, if you're dealing with right triangles, this tick mark pattern does actually guarantee congruence, and that's one reason is because of the Pythagorean theorem, which you've probably seen. I'm not going to go into it, we'll see it later in the year, but that Pythagorean theorem tells me if I know these two lengths, how to get this length. So what that implies is if a right triangle has this tick mark pattern, it actually does qualify as a congruence condition. So we give it a special name. We don't call it SSA. You should never write SSA as a congruence condition. Instead, we give it a special name based on the fact that we're using it for special triangles. We're only using it for right triangles. We call it HL90. Hypotenuse has tick marks, leg has tick marks, and there's a right angle. There's a 90-degree angle. I could call it HLR. I just like HL90. So this is what the tick mark pattern looks like, and it's a special tick mark pattern that only works for right triangles. If it's not a right triangle, this won't work. So let's do an example. So in this example, we're given DC is congruent to AE, so I'll tick mark those. B is the midpoint of AC, so there's A to C, and B is given as the midpoint, which means that it divides this into equal parts. And then AC is perpendicular to DE, so that means where AC and DE meet, there's AC across horizontally, DE down vertically. Where they meet, I get right angles. So apparently these are all right angles in here. And we're going to prove B is the midpoint of DE. So if I can get these triangles to be congruent, that would mean DB and EB would have to be congruent, and I would have my proof. So I already have tick marks on here, but this is not the SAS pattern. SAS would mean if these were my two sides, I would need to know this angle. This would be SAS with the angle between the two sides. This is the wrong tick mark pattern, except these are right triangles. This is a 90-degree angle. So this is exactly what the HL90 tick mark pattern looks like. You have the hypotenuse of each of the right triangles tick marked. You have one of the legs of each tick marked, and then you know that there's 90-degree angles. There's right angles. So this is the HL90 tick mark pattern. It's a special tick mark pattern that can only be used with right triangles. The way you write it up looks just the same as any of our other triangle congruence proofs. I say DC is congruent to AE. That's my hypotenuses in my tick mark pattern, and that's a given. My legs in the tick mark pattern are AB and CB. And those are congruent because of the midpoint statement up here. And finally, I have my right angles. And this is angle DBC. And this is angle ABE. And the only real new thing besides the new pattern is, since you need these to not just be congruent, but you need these to actually be right angles, you should say they're right angles. So I'll say they're both 90. And how do I know that they are both 90? I know that because of the perpendicular statement that was given in my givens up there. So these three things together create the hypotenuse, leg, 90 tick mark pattern. So that's enough to guarantee that triangle DBC is congruent to triangle EBA. DBC is congruent to triangle EBA using HL90. What did I want to prove? I wanted to prove B is the midpoint of DE. In order for B to be the midpoint of DE, I need DB and EB to be the same, but that will follow from this statement. There's DB and there's EB. So DB is congruent to EB by corresponding sides, and that implies B is the midpoint of DE. And that's because this is what it means for B to be the midpoint. This is definition of midpoint.